A 99% of people mistake this giant's identity. The Apatosaurus stands as a titan of the Jurassic period. Its very existence challenges our perception of terrestrial life limits. Though understanding this animal requires dissecting its unique, massive anatomy. The neck, disproportionately long, was a marvel of biological engineering. While its vertebrae were surprisingly lightened by complex, hollowed structures. Unlike later giants, its teeth were peg-like and positioned toward the front. And this suggests a feeding strategy involving rapid, bulk consumption of vegetation. While estimates place the adult Apatosaurus reaching lengths up to 75 feet. Or its weight remains a subject of intense biomechanical debate among researchers. We now zoom into the mechanics required to support such terrestrial mass. The tail was thick and muscular, essential for counterbalancing the neck's mass. It may have served as a surprisingly effective defensive or signaling mechanism. And now that we understand basic anatomy, let's explore its classification history. At the initial discovery of these giants sparked immediate scientific controversy. But the classification process in the late 1800s was often rushed and incomplete. And two seemingly different giants were initially described from limited fossil evidence. But one form, characterized by a specific tail structure, received the name Apatosaurus. The other, based primarily on neck and dorsal vertebrae, was labeled Brontosaurus. The decades passed where these two names represented distinct, separate genera. The turning point came when critical overlapping specimens were re-examined. Researchers concluded the variation was due to individual growth stages, not species difference. Under established naming conventions, the earlier name takes precedence, Apatosaurus. The name Brontosaurus technically became a junior synonym, a ghost name. Or yet, the public attachment to thunder lizard proved incredibly resilient. This era, the late Jurassic, was characterized by vast, verdant floodplains. And they needed continuous, high-volume caloric intake to fuel their massive bodies. The lacking complex chewing surfaces, they swallowed stones called gastroliths. This massive digestive tract required a huge central mass, giving the Apatosaurus its barrel shape. Its front legs were slightly shorter than its hind legs, giving a slight forward inclination. This posture also aided in reaching the highest, freshest canopy resources. Consider the cardiovascular challenge of pumping blood up that enormous neck length. Or it required an extremely powerful, multi-chambered heart structure far exceeding modern mammals. When submerged, water buoyancy would have greatly assisted in managing this immense weight. And aquatic environments offered both cooling and necessary skeletal support during resting periods. Evidence suggests the Apatosaurus possessed osteoderms, small bony plates embedded in its skin. But these offered limited defense against apex predators of the time. Despite its bulk, the skull of the Apatosaurus was remarkably small and delicate. But this small cranium housed a relatively small brain for such a vast body. And now that we understand its biology, let us revisit the taxonomic saga. But the original naming established a false dichotomy that persisted for over a century. The public image became firmly rooted in the popular, albeit incorrect, Brontosaurus moniker. To paleontological rules, prioritize the first valid scientific description, a necessary standard. The designation Apatosaurus entered the scientific record first, making it the valid term. However, the debate was recently reignited with new comparative analysis. But new studies suggest subtle but significant differences may indeed exist between the specimens. But this implies that two distinct, though closely related, sauropods might have coexisted. If confirmed, this reopens the door for the beloved Brontosaurus to regain its full status. Regardless of the specific label, the Apatosaurus remains a masterpiece of terrestrial gigantism. Imagine the ecological impact these immense herbivores had on their environment. At their eyes, those small surveyed a world shaped entirely by their consumption. And they moved slowly, deliberately, masters of their own massive, slow-moving domain. The sheer momentum generated by an Apatosaurus charge was virtually unstoppable. The tail acted as a powerful whip, a crucial kinetic extension of its body mass. But their grazing patterns created open meadows where other smaller species could subsequently thrive. We trace their paths today through deep, enduring impressions left in ancient mudstone. The pelvis formed a strong cradle, distributing immense vertical forces effectively downwards. The story of the Apatosaurus is intrinsically tied to how science corrects itself. On whether Apatosaurus or Brontosaurus, the scale of this herbivore inspires unending wonder. Its legacy proves that even the giants of prehistory continue to evolve in our understanding.